Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered why some music just sounds like it is all one thing, while other music sounds like separate instruments fighting for attention? This new study dives into that very question. It explores something called blend in music. Blend is how our ears take different sounds and make them feel like they belong together. Like one big sound. Now, most of the time, scientists think about how similar instruments sound to decide if they'll blend. But what if where the instruments are placed on a stage actually matters? This study investigates that surprising idea: does the space between instruments change how well they blend? So, what is this blend all about? Think about a full orchestra. You hear all the different instruments, but often they come together to create a rich, unified sound. That is blend. But then you hear a jazz band where each instrument has its own distinct voice, and you can easily tell them apart. That is less blend, or more segregation. Scientists have found that if instruments sound similar, they tend to blend better. For example, instruments with similar timbres like a clarinet and a bassoon might blend more easily than a flute and a trumpet. They've also looked at things like how quickly a sound starts, called the attack time, and how bright it sounds, called the spectral centroid. These are like the instrument's fingerprints that help us guess how well they'll blend. But here's the really interesting part. For a long time, researchers mostly ignored how the placement of instruments on a stage might affect this blend. Sure, composers have known this for centuries. Think about ancient church music where choirs would sing from different parts of the building, or even modern composers who put orchestras in different spots around the audience. They were using space as a tool. But it hadn't really been tested scientifically to see if this spatial separation actually changes how we perceive blend. This study decided to fix that. To figure this out, the researchers set up a cool experiment. They had participants sit in the middle of a circle made of 16 speakers. They chose 4 pairs of instruments that were known to have different levels of blend. A low blend pair, flute and bell. 2 medium blend pairs, clarinet and tuba. Violin and bassoon. And a high blend pair, oboe and trumpet. Then they played these pairs of sounds. One sound would come from a speaker at the front or the right side, and the other sound would come from any of the 16 speakers. This created different amounts of spatial separation, how far apart the speakers were. Participants then had to rate how blended the two sounds felt on a scale. So what did they find? The big picture is that, yes, spatial separation does influence blend. It wasn't a simple further apart means less blend for every single pair. The effect kind of depended on the instruments and where they were placed for the medium blend pairs like the clarinet and tuba. Or violin and bassoon, the spatial separation made a noticeable difference. When the sounds were close, they blended more. When they were far apart, they blended less. This was especially true when the instruments were on opposite sides, like left versus right. The high blend pair, the oboe and trumpet, showed something interesting. When one sound was at the front and the other was anywhere else, they tended to blend really well, almost like there was a ceiling on how blended they could get. But when one sound was on the right and the other was further away, they started to blend a little less. The low blend pair, the flute and bell, didn't seem to change much no matter where they were placed. They were pretty much always perceived as separate, kind of like having a floor effect they couldn't get any less blended. Now, they also looked at whether having musical training made a difference. They had musicians with at least 10 years of training and non-musicians with very little training, and they did find some differences. Musicians seem to be more sensitive to the spatial separation, especially for those medium and high blend pairs. They noticed when sounds were moving further apart, and it affected their blend ratings more. For non-musicians, the picture was a bit simpler. They mostly noticed when the sounds were well separated, particularly for the clarinet and tuba pair. But overall, they were less affected by the spatial separation than the musicians. This suggests that musical training might make us more attuned to these subtle spatial cues when listening to music. This is a really groundbreaking study because it is the first time researchers have experimentally shown that spatial separation directly influences how we perceive blend. They found that sounds closer together tend to blend better, and sounds further apart blend less, especially for pairs that already have some potential to blend. It's not just about how instruments sound alike, but also where they are positioned. Imagine a composer or a conductor. This research gives them concrete information. If they want two instruments to sound like one cohesive unit, especially instruments that are already somewhat similar sounding, placing them closer together on stage might help achieve that. If they want those instruments to stand out individually, spreading them further apart could be the way to go. For musicians playing in an ensemble, understanding this can help them adjust their playing and positioning to create the desired blend. Something really interesting happened with the flute and bell pair. It had a floor effect, meaning it was perceived as poorly blended no matter what. This makes sense, as a flute and a bell have very different sound qualities. The oboe and trumpet, on the other hand, had a ceiling effect in some situations, meaning they blended as much as they possibly could. The researchers did have to make a few choices. For example, they didn't test a left reference point condition, assuming that most people have similar hearing in both ears and that the results wouldn't be drastically different from the right reference point. Also, they used a simplified way to measure the degrees of separation to make the analysis manageable. These are important considerations for future research. What does this mean for us listeners? It means that our brains are really good at combining different sounds into a unified experience, but they're not just relying on the sound itself. They're also using environmental cues like where the sound is coming from. This adds another layer to how we understand and appreciate music. It highlights the complex interplay between timbre, space, and our perception. Future research could explore how this applies to more complex music, or even how we blend spoken voices or different kinds of electronic sounds. It is a fascinating peek into how our minds build the auditory world around us. So that is a look at this intriguing study on spatial separation and musical blend. It shows us that the physical arrangement of sounds plays a significant role in our perception. What do you think? Have you ever noticed how the placement of musicians on stage affects the sound? Let us know in the comments below. And if you enjoyed this dive into the science of sound, be sure to hit that like button, subscribe to RUBIN'S Mind Lab, and ring that notification bell so you don't miss our next exploration into the wonders of the human mind. Thanks for watching.